Hey guys, this is Mr. Mauricio, and sorry, but we have to continue, we have to move on. So I would like you to turn to page 250. We're going to be talking about congruence, and we're going to be learning about how to use properties of congruent figures to solve problems. Now, first of all, correspondence is a way of matching up two sets of objects, right? And congruent, as we were discussing in previous lessons, means that they have the same measure. Now, two polygons are congruent if and only if their corresponding sides and angles are congruent. So please, look at example 1. Example 1 says, write a congruent statement for each pair of polygons. So we have two triangles in part A. We have triangle MKL and triangle QRS. Now we have to write a congruent statement. Notice that in this example, we have these symbols. This means that segment MK or segment KM is congruent with segment SR or RS. This symbol means that segment KL is congruent with segment QR and segment ML is congruent with segment QS. So our congruent statement will be defining what angles are congruent and what sides or segments are congruent. So in this case, since the segments in example A are defined by those symbols, we can state the following. Okay, we can state that KM is congruent with KM1 with RS. We can state that KL is congruent, look, symbol 2, look, this one has 2, it will be segment RQ. And we can state that ML is congruent with SQ. Okay, those are the congruent segments. Now, if we look at the angles, angle K is congruent. Angle K measures 97 degrees, is congruent with angle R. Okay? Angle L, which measures 28 degrees, angle L measures 28 degrees, is congruent with angle Q. All right? With angle Q. And angle M, 55 degrees, is congruent with angle S. Okay? Now, since our segments or sides and angles are congruent, we can state, now look at this, this is very important on the way we call our polygons. In this case, I'm calling this KLM, okay? So we're gonna say that KLM is congruent, KLM is congruent with RQS. Okay? Notice, this is very important on the way we called our polygons. If we're stating that KLM is congruent with RQS, then this is very important. This means angle K is congruent with angle R, angle L is congruent with angle Q, and angle M is congruent with angle S. Okay? Also, we're stating that QL is congruent with RQ, LM is congruent with QS, KM is congruent with RS. Okay? This is our congruence statement. Now, if we look at example 2, okay, same instructions, we have to, sorry, this is example 2. If we look at example 1b, we have to do the same. Okay, write a congruent statement. Now, notice that here, they are not defining what sides are congruent to which side, right? So we're going to assume that all of the sides in the polygons, in both polygons, their corresponding sides are congruent. So in this, our congruent statement, it will be defined just by their angles. So I'm gonna call this pentagon A, B, C, D, E. Okay? So here we are. We have our angles, right? And let's see angle A. What's the measure of angle A? Angle A measures 100 degrees. Okay? So what will be its corresponding angle? In this case, angle H measures 100 degrees, so we can state that angle A is congruent with angle H. Angle B measures 130. So in this case, I measures 130. So we can state that angle B is congruent with angle I. Angle C measures 85 degrees, right? Angle J, measures 85 degrees. So we can state that angle C is congruent with angle J. Angle D measures 105. Angle F measures 105 degrees. So we can say that angle D is congruent with angle F. And finally, angle E measures 120 and angle G measures 120. So we can state that angle E is congruent with angle G. Knowing that, okay, again, since they're not defining what sides are congruent to what side, but we can look, just by looking at them, we can tell that the pentagons are equal, but in a we have a transformation. Pentagon HIJFG, it looks like if it was flipped, right? So we can state our congruent statement will be that pentagon A, B, C, D, E is congruent. Look, A, B, C, D, E, A, B, C, D, E is congruent to H, I, J, F, G, H, I, J, F, G. H, I, J, F, G. Again, okay, this is our congruent statement. If this is true, then we can say that angle A is congruent with angle J, angle B is congruent with angle I, angle C is congruent with angle J, D is congruent with angle F, and E is congruent with angle G. Okay? And we're also saying that AB, side AB is congruent with HI, BC with IJ, CD with JF, DE with FG, and AE with HG. Now if we look at example 2, in example 2, they're telling us that the figures, in the figure, quadrilateral PQRS is congruent with quadrilateral WTUV. Again, now we know that they're congruent, okay? So in part A, we have to find X. Okay, quickly, before we do that, since they're telling us that they are congruent, we know then that P is congruent with W, angle Q is congruent with T, angle R is congruent with U, angle S is congruent with V. Okay? So our congruent statement means P, Q, R, S. Angle Q, P, angle Q, angle R, angle S, they are congruent with, right? Angle W, T, U, V. And we know that PQ, side PQ, congruent with WT, QR with TU, RS, UV, and PS with WV. Okay? So part A, it says find X. Notice, we have X here. X is located at side, sorry guys, there was a mistake. It was pentagon PQSR, PQSR, and pentagon WTUV. Okay, so angle P is congruent with angle W, angle Q is congruent with angle T, angle S congruent with angle U, and angle R with V. And we can say that PQ is congruent with WT, QS, TU, SR with UV, and PR with WV. So again, find X. X is located at the line segment or at the side PR. 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 Right? So segment PR is congruent with WV. WV. So where do we have WV? Here. WV is congruent with WV. So what is the measure of PR? PR is X plus 5 equals WV 12. Now we solve for X. If we're adding on this side, we want to leave X by itself. So now we have X equals 12 minus 5. So X equals 7. Part B says find Y. Y. Where do we have Y? Y is located at this side. Okay? So notice Y is at TW. TW is congruent with what? Look, TW or WT is congruent with PQ or QP. So PQ, right? So TW, what is the measure of TW? 4Y equals, TW is congruent to 4Y. So PQ, what's the measure of PQ? PQ equals 24. Okay, so we have to find Y. Since this is a multiplication equation, we have to divide by 4 on both sides. And we get that Y equals 24 divided by 4. Y equals 24 divided by 4 is 6. The last part says find Z. So if we look, let's find Z. Where do we find Z? C is an angle. Angle V. This is 6Z degree. Now, if we look at our congruent statement, angle V is congruent with angle R, right? So we write angle R is congruent with angle V. So what is the measure of angle R? R equals 100. R equals 132 degrees. Equals angle V. V measures 6Z degrees. Okay? Now, we simplify. Okay? We want to find C, since this is a multiplication equation. We solve this by division. We're going to divide both sides by 6. And we get that angle Z equals 132 divided by 6. Right? We can simplify 132 and 6. They are divisible by 3. Okay, so how many times does 3 fits in 132? 3 in 13 is 4, that's 12. 3 in 12, that's 4, 44. How many times 6 divided by 3 is 2? 44 divided by 2 equals 22. So Z equals 22 degrees. Okay, and that's it. Now, a quick review. Once they give us, or they tell us that two polygons are congruent, like in example 2, polygon PQSR is congruent with WTUV, right? So we can state that angle P is congruent with angle W, angle Q is congruent with angle T, angle S with U, angle R with V. Sides PQ with WT, QS with TW, SR with UV, and PR with WV.